Alright, if y'all are here, thanks for joining us. I just sent an email out. Our teachers meeting ran a little late. Basically what the email says is we were talking about graduation. We did set a graduation date 2 weeks from today on June 16th. That's a tentative date. Hopefully we have it finalized in the next day or two. And we're going to get you a bunch more info on that. I got to post a couple more links on Classroom to invite people, but then the lesson will start in a couple minutes. Thanks for being patient. Marco, how you doing? I assume DeJulie is the real Gokage. And Marco, if you want after this lesson, if you bother me, we can send me an email and we can finish that last Khan Academy assignment. DeJulie, it's great to have you. Sorry you're having some tech difficulties. And it's good to have anybody else who's joining us right now. We're going to get started in 1 or 2 minutes. I just want to give kids a chance to click on the link. The good news, if you read the email, we set a graduation date. Tentative means it's likely the graduation date, so technically it's tentative. In a day or two, we're going to send you more info about some stuff and what we're doing for the graduation ceremony. And the date, I know Marco, you're eager. The date is going to be Tuesday, June 16th. It's going to be a virtual ceremony. We're going to give you a bunch more info. We're going to be asking for students to submit some stuff too. But in a few days, as teachers, after we meet a second time, we're going to send you info about what's going. No, Marco, it's going to be a virtual ceremony. Unfortunately, we can't gather at the school. But June 16th will be your official last day as 8th graders, so that's 2 weeks from today. And that'll just be a celebration day where we're kind of celebrating your accomplishments and moving on. Nashni, great to have you with us. I'm going to keep waiting for a minute or two. If y'all have questions, you can put them in the chat for now, and then we can get started on the lesson in a couple minutes once kids have had a chance to click on the links I sent out. Alright, like I said, I'm sorry we got going a little late. Thank you for the 3 or 4 of you who are here. Donald, good to have you joining us, man. So we're going to keep waiting a minute or two. No, DeJulie, you don't have to show your face for the graduation. If you don't like being on Zoom and having the video showing your face, you definitely don't have to do that. You can keep the camera off. I think our plan right now is to allow you all to send us a picture of you that would kind of play in a quick montage as we recognize all the graduates. So you could have that opportunity. You can also just have us display your name and no picture at all. But during the ceremony, while you're kind of watching and listening, you don't have to have your camera on, no. Alright, if you've got any other questions, feel free to put them in the chat. If I don't see any other questions in the chat, I'm going to get started on the lesson for math. Yep, you're definitely Marco, and anybody, if you want to dress up and look good for the graduation day on that virtual day, you're welcome to do that. But no pressure if you'd rather be in sweatpants and a t-shirt while you attend. Alright, with that, it looks like we don't have any more questions. So I'm going to get started on today's lesson. How are we going to get our diploma is a great question, Nashni. That's a question I just asked Mr. Rollins. It's a question he's asking his bosses this week. We are advocating that they should print diplomas and mail them to you all. That's the easiest way for you all to get them. But so far, from what we've heard, the city needs to get moving and hasn't figured out how they're going to get diplomas to kids yet. But we asked Mr. Rollins, he's asking his bosses, so hopefully in the next week or two we got more information on how to get the physical diplomas to you. And if you've got any other graduation related questions or anything for that matter, put them in the chat. And once we kind of reach a minute where the chat's quiet, then I'll start the math lesson. And can I ask, for those of you who are here, how many of you are really excited to get the diploma and that's like the biggest thing you want? And how many of you just could care less about whether or not you get the diploma? I'm curious, just because the teachers and the principal were curious how excited you were about it. Me. Alright, so Marco's excited to get the diploma, and it seems like some of the kids, most of the kids I've talked to are. So if that is the case, we will do our best to keep bothering the city of Boston and make sure that we can get you official diplomas as soon as we can. Yes, you all are going to be in 9th grade next year, so that's why we're going to do some math. This is definitely related to some of the math you'll be doing in Algebra 1 next year as a 9th grader. Okay, so I'm going to zoom in a little bit to make it easier to read this first problem. As we go, I'm going to try to mark some of this up as we go. If you've got questions and you're live with us, put them in the chat. Tell me things don't make sense, and I'm happy to slow down a bit. So today's whole lesson is pulled from the first 2 Khan Academy assignments this week. They're about word problems that have to do with proportional relationships. So you worked with proportional relationships last year with Mr. Neville and us a bit this year. I think the challenge for some of these is they're word problems, so we need to understand how to make sense of equations in these word problems. For every word problem, I think the biggest, most important thing to do, if it's a word problem, is to carefully read through everything once and just try to get a sense of the story. Understand what the story or the situation's all about. And then I identify the question, and now I go back to the story, I dig in, and I see, okay, now that I've made sense of the story, and I know what the question is, what information do I need? So for this first one, as we're reading, it tells us that bamboo is one of the fastest growing plants. A typical growth rate for bamboo in temperate climates is 3 to 10 centimeters per day during the growth season. So I see this problem's about a plant that grows, bamboo, and specifically they give me some numbers about how quickly the bamboo grows. The word problem goes on and they say, which of the following equations, where T represents time in days and L represents length in centimeters, could describe the growth of a bamboo plant? Choose all that apply. And I'm going to go back into that problem because I really see now, okay, they're talking to me about a bamboo plant, and what's the question? And I see it's a little broken up, but the question really says which of the following equations, and then they use commas to describe the variables. T is going to be time, L is going to be length in centimeters, but they want to know which equation could describe the growth of a bamboo plant. And I see here they've listed the equations they're referencing, 4 different equations here. And I think what's important, we can see they tell us for these equations, L, right here, L is going to represent the length in centimeters and T represents time. And every equation you should be able to translate into a sentence if it's a word problem, to make sense of it. Here, L stands for the length in centimeters. So the length of the plant is equal for A to 1.1 multiplied by T, and here T is the number of days. So really all this equation's telling us, this first equation, if I understand it, it says L, or the length of the plant, can be found by taking the number of days and multiplying those number of days by 1.1. What that would really mean here, and I'll switch color a little bit, that would really tell me this plant grows by 1.1, and T is represented in L is in centimeters, by 1.1 centimeters every day. And then every one of these should say something to me. The second equation says this plant, whatever plant we're talking about, its length grows by 2.5 inches or centimeters every day. This one says 7.1 centimeters every day, and this one says 9.3 centimeters every day. And I know here, so which equation could describe the growth of this bamboo plant? The big key that we need to see, and I'm going to underline this here in purple, is the bamboo plants, they grow 3 to 10 centimeters per day. So I need something that's showing me something between 3 and 10 centimeters per day. And then I see that C is the only one that has a growth rate somewhere between 3 and 10. A and B are too small, so I'm going to go ahead and get rid of A and B because those are showing 1.1 and 2.5 centimeters per day, and the bamboo grows at least 3 centimeters per day. So we're going to go ahead and put red through those. And then I know that the 9.3 one is just too big. At 9.3 T, that's telling us some plant that grows 9.3 centimeters for every year. So that's too... Ooh. I read the problem wrong. It says choose all that apply. And we see 9.3 T is actually smaller than 10. So as I'm going through process of elimination, I realize, wait a minute, C and D are actually both potentially correct answers here. So my mistake should be telling us something more important here, Marco. Maybe you can tell me the most important thing. I need to read every piece of this carefully. If they say choose all that apply, I may have 2 answers. Sorry, it's not highlighting. And in this case, both C and D can be correct because 9.3 centimeters per day would still be less than the 10 centimeters per day, which is the maximum for this plant. I do agree that the word problems get tougher. Marco, Nashni, those of you with us, I think the biggest thing is to make sense of what the variables stand for always. And hopefully the next couple problems in your practice on Khan Academy can help a bit. So again, with every one of these, we're going to see this for number 2. We're going to really focus on what variables do they use and what do those letters stand for. So on problem 2, we're told that Usain Bolt is considered to be the fastest person on Earth. He holds the record for the fastest 100 meters, in which he ran 9.58 seconds in 2009. Assume Bolt ran at a constant speed. How you doing, Michaela? It's good to have you with us. We're just starting on the second problem here. I'm going to show you very quickly a picture of Usain Bolt. I think hopefully some of you recognize Usain Bolt. If you were watching the Olympics back 4 years ago, he's won the Olympics for quite a few times in a row. And 4 years ago, again, he was winning in the Olympics. Sorry, it's a little slow to load, but in the images in a second, I think we'll recognize who Usain Bolt is. So here he is. Hopefully looks familiar. He's getting older now, but considered the fastest person to ever run, and he's won lots and lots of gold medals. Now, they told us about Usain Bolt. They said the story is talking about how fast he runs, and he runs 100 meters, and specifically he runs those 100 meters in 9.58 seconds. So I'm going to pull up some of my notes and clean up the ones from the old problem. And here I'm going to underline what I think is the key thing that I saw as I'm going through. They tell me that Usain Bolt is going to run how fast? He's going to run 100 meters, and he's going to do that in 9.58 seconds. So that's pretty important to see that data point, that speed. He's running 100 meters in 9.58 seconds. Now the question itself, which I'm going to put in red here, the question says which of the following equations, and I'm going to skip a part for a second. They describe to me what the variables mean. They like to put all this annoying sentence. We'll come back to that. But they say which of the following equations describe a speed that is greater than Bolt's record-breaking speed. So I'm going to even put a red box around this word greater. And that's really telling me, hey, I'm looking for equations, not equations that are equal to Bolt's speed, but equations that are greater than Usain Bolt's speed. And then the important thing to see about the variables, they do tell us, I'm going to go ahead and in purple, I'm going to list what the variables stand for. The variable here, D, is going to stand for the distance, or how far Bolt runs, and then T in these equations is going to stand for the time, and that's measured in seconds, and the distance, in this case we're measuring how many meters he runs for distance. And what I see from the data up here, the speed that I'm given, I know Usain Bolt's speed, his distance, he runs 100 meters. So I'm going to go ahead and borrow that 100 meters. He runs 100 meters, and to do those 100 meters, it takes him 9.58 seconds. And last year with Mr. Neville, this year with us, we've talked about rates or speeds. Any rate or speed, when you say 100 meters per 9.58 seconds, you should think of a ratio. And anytime we have a ratio, it's just a division problem. So if I do 100 divided by 9.58, which I'm going to do on my calculator here, if I do 100 divided by the 9.58 seconds it takes, I get 10.4. If I round this off, it's going to stop at 10.4 to the nearest 10. So that would tell me here, hey, he also runs, if I simplify this, about 10.4 meters every 1 second. And that's really the key here, I think, to see, is that Usain Bolt's speed every 1 second, if he does 100 meters in 9.58 seconds, we can simplify that rate to 10.4 meters every 1 second. Now, what's important, I actually rounded my answer a little too bit. I'm going to go back to this. It said 10.438, so I'm going to go ahead and add that 10.43 in here just for a second to help us out. It would actually go to 10.44 if we round up. Either way, this is important to see now. I'm looking for the equations that describe a speed greater than Bolt's speed, and if Bolt is running 10.44 meters per second, which of these equations shows a speed greater than that? Well, the first one, A, shows us 10 meters per second. Put that in black there. This one's 10 meters per second. And that's just too slow for us. So if that's too slow at 10 meters per second, 10.2 is also too slow. And believe it or not, 10.4 is also slower than Usain Bolt's speed, because he was at 10.44 when we actually did that out. So the only correct answer, we get the only one that's faster than Usain Bolt's speed of 10.44 or greater, is this last one here for D. That equation is showing me Usain Bolt running at a speed of 10.5 meters per second, or whichever runner is there, and we know his record-breaking speed was very, very fast, but just 10.4 meters per second, a little slower than D. Sorry, I gave it the wrong color. I'm sorry that my computer's moving very slowly right here, which might make it a little hard to follow. I hope it's not lagging too much. But that's our correct answer there for number 2. For those of you who are here with us, definitely as you're doing Khan Academy, if you're working on this and having trouble making sense of the problems, I'm happy to work with you one-on-one. We're going to keep moving here. And again, you're going to see our focus will be on making sense of the story told by the problem and also what the variables stand for. So number 3 for our word problem, as we start reading through it, they tell us the unit rate of change of y with respect to x is the amount y changes for a change of 1 unit in x. I think it's important to see here, sometimes Khan Academy, like this problem, gives you sentences where there's a lot of information that might not be too necessary. All this is really doing is defining rate of change, is saying it shows how much does y grow compared to x. And I think you all know rate of change is y growth compared to x. The problem then tells us the table below represents a proportional relationship with a constant unit rate of change. So here they told us a unit rate of change is really how much does y grow over x, and they say the table has a constant rate of change. They then say which describes a greater unit rate of change. The equation y equals 0.25x or the table. This is a complicated question. I've worked with a few students already on it on some other Zoom meetings who are working on Khan Academy, and I think the challenge is it's very wordy, but you want to focus whenever you get confused in these word problems on where is the question, and that usually comes at the end. And here for us, let me clean up the notes from last problem. Here for us, as usual, the question comes at the end. The question says, which describes a greater unit rate of change? And then they give us two options, the equation, y equals 0.25x, or the table. So in red marker, I'm going to go ahead and put a red circle around this equation, because that's one thing I'm comparing. And then on a different color, we'll go ahead and choose green. I'm going to compare that to the table. And I see the table is the data down here. So one challenge about this problem is seeing we really have two different relationships in play here. One is the equation, and two is the table. And they want us to compare who has the greater rate of change. And rate of change is really like slope. It's another term for slope, and we've already talked about this year. And slope measures how quickly y grows compared to x. Same thing with unit rate of change. So I want to look here for the equation. The equation is in y equals mx form, and I see the slope, the rate of change for the red equation is ultimately going to be 0.25 for a rate of change. So the equation, they're hoping you recognize any equation in this y equals mx form, the slope or the rate of change is the number multiplied with x. That tells you how much y grows for every 1x. And on the table, I'm going to have to measure that rate of change. I look at how much y grows by, and I see that y goes from 0.4 to 0.8. And if y goes from 0.4 to 0.8, that means it grew. Specifically, it gained 0.4 units. From 4 to 8 is growing by 4, so 0.4 to 0.8 is growing by 0.4 units. And during that time, the x had to grow as well, and the x goes from 1 unit to 2 units. So that means that our x value has grown by 1 unit, and at the same time, our y value has grown by 0.4. So if I set that up as a slope, as a rate of change, that tells me for the green situation, the green rate of change is 0.4 over 1. And anything divided by 1 is just itself, so that tells me, hey, every time x goes up 1, y grows by 0.4. So the rate of change on this table is 0.4. All that means is y goes up by 0.4 every time the x goes up by 1. So I need to compare what's greater, 0.4 or 0.25. And what's helpful there, I think, if you're a little confused about what's bigger, 0.4 or 0.25, if you think about it like money, 0.40, which is the same thing as 0.4, 40 cents is more than 25 cents. So based on all of this, it tells me that the table has a greater rate of change. So I'll go ahead and put that in here and then pull the work back up. The table has a greater rate of change. And the explanation I'm going to use, I'm going to keep my explanation simple. I'm going to say 0.4 is greater than 0.25. So that's kind of the last one we took from the first Khan Academy assignment. And the difficulty on some of those Khan Academy ones is they give you two different relationships to compare. So anytime it happens like that, really just focus on what's the rate of change for one versus what's the rate of change or the slope for the other, and then you should be able to make the comparison. I'm going to go ahead and clean that work up. I'm going to move on. Looks like we still have 6 of you with us here, so if you've got questions, put them in the chat. If you want me to stop and you want to talk about graduation, put that in the chat, and we can ignore problem 4 and 5. But I will keep moving down to problem 4 for now. Alright, I have to zoom out a little bit so we can see problem 4 better. And problem 4 and 5 are examples of problems that you will see on the second Khan Academy assignment this week. They're again making you work with proportional relationships where they make you build your own graphs. You've actually done a little bit of this with Mr. Neville last year and then a little bit of this with me earlier in the fall this year. When I graph proportional relationships, which is what assignment 2 on Khan Academy is all about, and number 4 and 5 are about, the key is to, I'm going to pull up my notes, we can think about slope-intercept form. proportional relationships are the easiest types of linear equations. They don't have a y-intercept at all. The y-intercept, as you recall, is 0. So when I look over here at this equation, which I'm about to mark up, I see it says y equals 2.5x. So that tells me for this equation, the slope is 2.5, and also, right, that slope is that 2.5, and then I also know the y-intercept is 0 and 0. Hopefully we remember from Mr. Neville last year that every proportional relationship starts at the origin, 0 and 0. And now hopefully as an 8th grader you see, oh, that's in part because their y-intercept is a plus 0 and it's just not listed there. So my slope is 2.5, my y-intercept is 0.0, and that information is going to be very helpful when I have to build a graph. To make this graph, you're going to have to double click on it to start editing it. And then a little more challenging than Khan Academy, you got to drag the dots instead of just click. Here I'm going to remind us our slope was 2.5, our y-intercept was 0 and 0. So the first dot, or the first point I'm going to plot for every proportional relationship is the easiest one to find. It's that y-intercept. So I'm going to go ahead and plot that green dot right on the origin, and that represents our y-intercept. Now the slope is 2.5, and we could really translate that slope a little bit further to say the slope here, give me 1 second, the slope here is going to be 2.5 over 1. Anytime the slope's a whole number, you can just put it over 1. And if slope is my rate of change, rise over run, that means I'm going to have to go up by 2.5 units, because that's the y growth, every time I go right by 1 unit. But the challenge here, and this is where Khan Academy can be jerks, is that the graph doesn't count by halves. Jennifer, it's great to have you with us. To answer your question quickly, and we can talk more about it, we're thinking June 16th is our tentative date for graduation for the 8th graders. And we can get you some more info about that after I finish this problem. Again, the challenge here though is going to be, if I try to count up by halves, this grid box doesn't go by halves, and Khan Academy doesn't let me plot by halves. So I need to transform or change this unit rate into whole numbers. I don't want a decimal, I want a whole number for my y and my x change. And I know anytime it's a half, if I double it, if I multiply by 2, then that's going to give me 5 over 2. For a slope. Jennifer, I promise I'll get into more answers here in a second. So a big thing to see here, if my slope is 2.5 over 1, that really means that I'm going to have a slope of positive 5 over 2 as well, and that's a bit easier to work with. Going up by 5 and right by 2 is easier and in fact possible on this graph. So this is where that second dot's going to go. Then you again could keep following it. You could go up by 5 more and right by 2 more to put a dot here, or you could even go backwards. 5 over 2 is the same thing, going up by 5 and right by 2. The same pattern is to go down by 5 and left by 2. So all of these purple dots that you see on my screen right now are different points that we could use for our graph. If you do want to be able to go ahead and drag that line, the green line, you don't have to do that, but the way you do it on Google Documents, we'll put a couple of these dots in here first. For Google Documents, if I want to go ahead and drag one of these lines, I click on it first. And then if you see the blue dots on the two ends of the line, that can drag either edge of the line. So I'm going to take this one, drag it up here on that dot, and then I'm going to use the other edge of the line, drag it down here, and I'm going to position it so it gets through all of these dots, and that gives me my graph. Again, we kind of got to that graph by recognizing the y-intercept. It was a proportional relationship when it's y equals mx and there's no plus b listed. So we graphed the y-intercept, and then we changed the slope to 5 over 2 to make it a little easier to graph. So Michaela, Jennifer, to recap, our hope is 8th grade, and Mr. Rollins' idea today is a tentative graduation that is going to be on Zoom. Unfortunately, we can't do it live, but on Zoom we're kind of going to have a promotional ceremony for you all on Tuesday, June 16th is the date. We were thinking 11 a.m. That was our best compromise between something that has to happen in the morning, but also recognizing that you all kind of like to sleep in a bit at this point with different schedules. So hopefully, tentatively, and I'll put this into the chat too, tentatively we're going to have a Zoom graduation and held on Tuesday, June 16th at 11 a.m. Our thinking so far, I guess, what were you all were hoping for? Because it sounds like you're disappointed with that. What were you hoping instead that we would do? And I'll wait. There's a little delay, but that's okay. Go ahead and put in the chat, I guess, what you were hoping to do. Nothing. Go to school. Yeah, I think definitely all of us, Mr. Rollins, all of the teachers, your family members, we definitely would have absolutely preferred to be able to go in person and hand you a diploma and do a traditional graduation and see you all physically in person one time before the year ends. Unfortunately, that's not an option. The city has made very clear that none of that can be happening and nobody can be on school grounds. So the best that we've been able to come up with, and the best we can do is to kind of at least have some kind of Zoom thing where, number one, teachers can have video recorded messages to kind of recognize and say things to you, both teachers who are 8th grade and then maybe teachers you had earlier on. And we enter inside 3x3, 6 feet away. All good ideas, Jennifer. Unfortunately, when you're in a big city like us, you kind of just got to play with the rules that the city gives you. So you'd have to protest Mayor Walsh if you want the city to be allowing students to actually go into their buildings to graduate. So one other thing, yeah, we will record it, Marco, so that if people are not there live, that they could at least watch the recording at some other time and see the messages that the teachers kind of sent. We're going to meet more on Thursday as teachers to get details about what we kind of want that video and that promotional ceremony to look like on Zoom. But if you all have ideas about what you think should go on, feel free to either put them in the chat or, better yet, is send me an email with the ideas. Michaela, I see a request for later in the day. The Mildred people wanted to actually have it earlier. And Coach Maddie, who was there in the meeting, and I were both advocating for later. And about 11 a.m. we thought was the latest we could push it. Whether or not you need to dress up, you're not required to dress up. And Julie, I think, had asked earlier, do I need to even be on camera? You can leave your camera off the whole time if you want. You can show up in sweatpants and a t-shirt and turn your camera on. Or you can be dressed up as much as you want. I think you'll see some kids, want to be excited and dress up. It's totally up to you. That's maybe one benefit of doing a Zoom graduation at home is if you want to dress up, you can. You can turn your camera on. Can take pictures at home kind of with your family and stuff too to kind of memorize the day. Or if you want to keep it more low-key, you can dress in sweatpants, keep your camera off, or even keep your camera on, join us in a t-shirt. That's cool. So yes, Marco, that does mean, assuming this goes through, and Mr. Rollins seemed pretty confident on that, June 16th would be the last day for our 8th graders. You guys get to finish a little bit earlier. I think other students are going to that next week, but we were going to hold our 8th grade promotional ceremony on June 16th, and because 8th graders usually get out a week early. Jennifer, so how can you tell people that you've graduated? So we're going to run part of the little Zoom ceremony, the Zoom video. We'll be recognizing each student, so it'll kind of put your picture and your name up there to kind of, so everyone can clap for you and say you were graduated. We're going to give you all an opportunity to submit to us the picture that we use for that. If you don't want your picture up there, we can absolutely just put your name up instead and no picture. That's totally fine. Some of that, we're working those details out as teachers in a couple days. Oh, I'm sorry. Miss Battaglia, could you just say who your child is? I thought you were Dafka, Jennifer Battaglia, the student. Or is it Jennifer and you're using my child to reference someone else? I'm a little confused. Alright, so if there's not more graduation questions, like I said, we will get you more details on that as we start getting them from the city and finalizing them at the school level. But if there's not more questions, I'm going to wrap up problem 4 and then also go into problem 5. Alright, so for problem... Wait. What is it, Margot? Alright, Marco, let's get through 4 and 5, and then some of this stuff we can definitely chat a little more about if you want to stick around, or we can even open Zoom up. I'll probably do that. I'll open Zoom up after that. So let's get through 4 and 5. I'll open a Zoom up quickly if you all want to join there and ask questions, and that might be a little easier. So, as we get to part B here, right now you have that graph up there, and we had a slope of 2.5 over 1. And we kind of changed that to 5 over 2 to build our graph. And the origin, the y-intercept, started at 0 and 0. So part B is one of those true-false questions. They really say to us which of the following statements are true. Choose all that apply. That's an important thing. There's going to be more than one right answer. And whenever I see a question that says which of the following statements are true, I just kind of go answer choice by answer choice and treat each one like its own little individual question. A drive-through. I'll talk about that more, Michaela. People have proposed that idea. So within this graph, the first one says the equation represents a proportional relationship. And from Mr. Neville last year, you all got the basics of a proportional relationship. There are 2 things for a proportional relationship. One of them is that it needs to be a straight line if you're looking at the graph. And you might remember the second thing you talked about at the beginning or the end of 7th grade, the beginning of your proportional relationship. It had to be a straight line, and what's the other thing? It has to pass through the origin. Any graph that is a straight line passing through the origin is going to be proportional relationships. We did a lot of work with that. The equations will always look like y equals some number times x. It's just a simple equation, and that's why it ends up starting at the origin and going in a straight line forever. So both this equation's format, that there's no y-intercept, and the graph's appearance, that the graph is a straight line passing through the origin, both of those are proof that A is true. And now that you're saying my diploma, can I clarify, Jennifer, that this is Jennifer the student in my class? And I'm also curious who you were referencing when you said, how will your child know? But I might be less confused. Well, you type the answer to that, Jennifer. I'm going to look at B. B says the unit rate of change of y with respect to x is 2 over 5. So if they're saying the unit rate of change of y with respect to x, and every unit rate of change we do of y over x is 2 over 5, that would mean that we would have a slope y gaining 2. Give me 1 second. Y gaining 2 as x is gaining 5. And that's not what happened here. We actually saw the opposite. Y was gaining 5 as x was gaining 2. So our slope here really was y gains 5 as x gains 2, and they're being jerks here on B. If you see the 2 and the 5, you might be tempted to pick B, but that's a distractor. Next up, is part C. Part C asks you about slope. Slope is a term we started to bring in 8th grade whenever we work with any linear graph, whether it's proportional or not. And slope is always going to be the m in your y equals mx plus b equations. It measures how much you go up, the y change, compared to how much you go sideways, the x change. Marco, for this, I didn't create the problems. I'm actually just pulling ones from Khan Academy because I think that's more helpful at this point of the year when we can't meet in person. So these truly are actual Khan Academy problems that are related to the ones you're going to see. So here we should see for a couple different reasons why C is correct. The easiest or most obvious way, if slope is always the m in the y equals mx plus b, here I see that the slope is multiplied with the x, or in this case, the 2.5. So that's the first thing that tells me slope is 2.5. The other thing, we were going up 5 and over 2, and if I do 5 divided by 2, that gets me back to that slope of 2.5, if we kind of unpack that. So there's a few different reasons to see how the slope is 2.5, and that C is one of our correct answers. For D and E, they're very similar, and when I see things like this that are almost opposites of each other, I'm thinking, well, only one of them can be true, and there's a pretty good chance one of them is going to be true, but they can't both be true. For D, they say, oh, and I typed this wrong. This should say a change, not a chance. So for both of these, it should say a change at the start. So a change of 5 units in x results in a change of 2 units in y. And E gives us the opposite. E says a change of 2 units in x would result in a change of 5 units in y. And what we saw when we turned... Okay, Michaela, that makes a lot more sense, and thank you for explaining that. So this 2.5 we changed into 5 over 2, meaning y gains 5 as x gains 2. And if we have that understanding, up by 5 for y, right by 2 for x, that should have made E hopefully a little easier to pick out for us as the correct statement. And D is a lot like the distractor from B. They've got the slope or the unit rate mixed up on purpose. At this point, I'm going to cut the YouTube lesson, and I'm going to create a Zoom meeting. And I'm going to just post that Zoom meeting as a link on your Google Classroom. So if you want to talk about the graduation stuff that's coming out, or you want to get math help for the next 10-15 minutes, we can do that. So I'm going to wrap this meeting up. I'm going to post a Zoom on your Google Classroom for y'all to join. And then if you're somebody who's watching this recorded later on and the video is kind of choppy, I'm sorry about that. As we were talking about graduation stuff, if you still need help, please send me an email and I'm happy to jump in. Marco, go log on to Clever, click into Google Classroom, and then on Classroom you will see the link. I don't really want to email a second time. Maybe I will. Alright, I'll see you guys.